welcome back. We continue to explore what we're learning about the Gen 4 Coyote S650 and all the different little mysteries that come with it. Today, looking at this log, and riddle me this. I'm looking at this log, and I came here because as I work my tune, which is right here, I'm looking at my variable cam timings, and I'm trying to understand how the schedule is moving through the system as load goes up and down, right? And let me back up for a sec. All we're trying to do is tune, right? And I released a video the other day about how fuel trims on this car are governed by speed density. So if you're going to be tuning, all fine and well to dial in the MAF. In fact, it's a good idea to dial in your MAF. You will find, though, that after isolating it and turning back on the cylinder air anticipation and the other goodies, right, that put speed density in control, speed density has the final word on fuel trims. And so if you're trying to do just a basic tune, right, and I'm just tidying up my stock tune, it's already fine, right, but I'm trying to figure out how this car works, right, because power adders are in our future. So looking at my VCT schedule, just a reminder what that is, right? The car has a variety of mapped points. There are 26 of them. And those enabled map points can be called upon by the HDFX ECU as it's moving through all the different load conditions and what have you. The way it works, I've pulled up fuel economy here, is fuel economy has a distance table. This is it right here. And that distance table has load on one side, airflow, right? Load is airflow, and RPM on the other. And you can see here it references values, right? It can go from 0, 2.3, 3.0, 5, 7, right? And those are all calling to, under these conditions, it's calling to the lookup table, right? And this is the mapped points lookup table. And so, for example, if I am in a relatively low load condition, say 0.2, and I'm only at 1500 RPM, or I'll even say this, I'm at 2000 RPM, pretty low load, I'm going to call mapped point, or I'm going to look up the value of 2. And so then I would come up here and I'd say, okay, so this is my value 2 that I just called up. That corresponds when you know it's map point 2, right? And so mapped point 2, when I come over to the mappings on the valve openings, looking at my intake and exhaust, I see map point 2, 10 degrees, map point 2, 30 degrees, all fine and well, right? And as the system's driving around, you'll see it moving through these, right? So I'm logging this, and I'm trying to understand what the hell is going on, right? And again, we're Gen 4. Why is it, riddle me this, Batman, why is it when I'm moving through regular driving situations, I think my driving mode here is optimum stability, right? I know I'm in optimum stability for the most part. I'm moving back and forth between optimum stability and fuel economy. Regular driving, right? And look at my tables. I would expect to see 0 through 7, like we just saw, being called on all the time. But look, it's 10 and 11. And their other friends, 12 and 13, right? And you can see the HDFX moving through these in various positions. I'm just going back and forth now, right? And there are various other parts of the log as well where it's going through 10 and 11, right? So I've been going crazy trying to understand which of these tables out of all of them is referencing 10, 11, 12, 13, because that's the ones I'm seeing all the time. Went nuts, right? And finally, I came across something interesting, and that is this. If you go to a high load situation like this one, and you know, my charts, I haven't cleaned them up in a while, but they're good enough to see RPM. And as RPM is increasing here, you can see I'm pulling from the optimum power table. You can also see intake manifold runner control has jumped from about 1.5 to 3.2 or 3.3 volts. Okay. And when that happens, wouldn't you know it, when the IMRC is in a high voltage state, I come down here to these tables. How about that? And so if you reverse engineer this behavior, you will find, this is where I bring in the IMRC schedule here. These are our various IMRC points. And I'm going to stack them up here with my angles. Okay. Different to Gen 4, we have 3 tiers. I keep shooting myself in the foot, damn thing. 3 tiers, 0 through 9, which is when the intake is open, 10 through 19 when it's closed, and then other, which, spoilers, this is power. This is for optimum power moves through these, right? And if you look at your angles, maybe I can get this one back. Perfect. Okay. You can see, like other generations, right, 0 through 10, or 0 through 9, and then 10 through 19, they're copies of each other. They're exactly the same crankshaft angles that we're dialing in. One is for when the IMRC is closed. One is when the IMRC is open. And so the way we can now look for this in our tuning is tables 10 through 19 are tables 0 through 9. They're the one and the same. The difference is whether or not this voltage is in a high state or a low state. High state, low state. And now, having known that, we can account for that, and we can begin performing high-low speed density tuning, which is what I'm going to show you in the next video, and the results, I assure you, so far have been very promising. So look for that to come.